we need to prove the following. So let's begin from the left hand side. So here on the left hand side, on the first term in the numerator, we have sine cubed a plus cosine cubed a. We can use an algebraic identity. So whenever we have a cubed plus b cubed, then this can be expanded as a plus b multiplied to a squared minus ab plus b squared. So in a case, a is represented by sine a and b is represented by cosine a. That means we can now rewrite the numerator portion as sine a plus cosine a whole multiplied to a squared. So that means we have sine squared a minus a times b. That means sine a times cosine a plus cosine squared a whole divided by sine a plus cosine a. Then coming to the second term. So in the second term, we have sine cubed a minus cosine cubed a. So there we have another identity, a cubed minus b cubed, which can be expanded as the product of a minus b and a squared plus ab plus b squared. So we will have sine a minus cosine a whole multiplied to sine squared a plus sine a times cosine a plus cosine squared a whole divided by sine a minus cosine a. Now we can cancel out sine a plus cosine a from the numerator and the denominator. Similarly, we can also cancel out sine a minus cosine a from the numerator and the denominator of the second term. So this is going to leave us with, so we have sine squared a plus cosine squared a. Now sine squared a plus cosine squared a, that is a standard identity, sine squared a plus cosine squared a. So this is equals to 1. That means sine squared a plus cosine squared a minus negative sine a cosine a will become 1 minus sine a times cosine a. Similarly, in the second term, we have sine squared a plus cosine squared a. So that's 1 plus sine a times cosine a. So sine a times cosine a will get cancelled out, and we have 1 plus 1, which is equals to 2. And this is the expression on the right hand side. Hence, we have successfully shown that the left hand side is equals to the right hand side. Hence, proved.